you'd like, but.
Okay, we're going now. Go ahead, John.
Okay, welcome to the meeting. Sorry for the delay. We're not going to fool around here. Bill, you're up.
Bill is up?
Bill is up.
Can you ask people can you kindly ask people to be quiet? We can't hear on our end. Thank you.
All right, give us a minute.
Okay. So we still have money.
Excuse me, Tyler. Excuse me, Tyler. Can you mute up? Can you mute up the local one? We're hearing echo. Okay, please continue.
Go ahead.
All right. No, back it up.
Yeah, I'm sorry. Let me try to get out of this here too. So I can't do what I thought I was gonna do. So let's do that.
Take him out and shoot him.
I'm doing my best. All right, there we go. You want to, oh, now I'm scrolling through your, there we go. And you want me to get rid of this?
Yeah.
If I can. So now you're asking for stuff on the fly and making my life more difficult.
Okay, so, well, the important numbers are there.
How about
Wow, look at that. Operating account, we're
Nope.
still
There
at
you go.
9771, savings 1244, PayPal 1696. And I moved money from PayPal over to operating after the first of the month. But these are the end of month totals. Self-insurance is 1539. It's dropped a little bit because we had to replace 2 Wi-Fi antennas for link systems, and they had been damaged by lightning, thunder, and storms. So we paid for it out of self-insurance. Convention is holding steady at 4212. Total amount on hand right now is 43,553. We're up about $350, $340 for the month. Now that year to date, that's a negative number. We're still down $3,600 year to date. That's for those 4 repeaters that we bought. So Amazon Smile, $96 year to date. Members have donated $43.50. Membership, that's not $18. That is 18 renewals handled during the month. And ARRL commission, we get $5 each time somebody renews. So far, we've gotten $15 from them. They're about $20 behind. PayPal Giving Fund is $57. Total donations $45.03, and that membership years, that's not in that $45.03. That's the number of memberships that renewed during the year.
Thank you. So as you can see, members, 437 currently. ARR members is 312, so we can always do a little bit better there. We've got 7 new members who have signed up in the month of August. 18 renewals, and then we're holding at 47 examiners. So that's pretty good there. Any questions about any of that?
We just got one new member.
Yep.
Signed up.
Okay,
I
all
got
right.
the check. It hadn't cleared the bank yet, so she's not a member.
Okay, so on the 17th is the swap meet out at Cabela's. Does anybody not know where Cabela's is? Okay, so the east parking lot where it's always been, pull into the main front there, make a left, and it's back in the corner there. So starts at 8 a.m. sharp, not before. Okay.
Good luck with that.
Yeah, good luck with that. Vendors can come in early and get set up, of course. So, and that's that. So, Barry, do you have Chuck in the wings?
Chuck is in the wings. Before we go to him, let's see if we have any comments or any other club
it's
business.
not that convenient, sorry.
Of course not.
Yeah, hi there. Can you hear me?
Yeah, that
Okay,
works.
so before Chuck is in the wings, before we go to him, let's see if there's any other club business.
Okay, try that, Barry. There we go.
I'll get a little echo here. Yes, Chuck is in the wings, ready to go. Is there any other club business before we go to him? Guess not. Okay. So let's just do one recording since the meeting was so short today. Welcome to Chuck Abramson. He is the, I believe, Vice President and Technical Person for ABR Industries. I'll let him introduce himself. He spoke back about 6 months ago about coax, and he's really good. Today he's going to talk about lightning and how it affects the ham shack. So let's pull down your screen here. And Chuck, come off mic if you would. I think you are. And Chuck, go ahead and bring up your screen share.
Okay, can you guys hear me?
Yeah, perfect.
Okay, all right. So, and let me just share my
Okay.
screen here. 1 second with that. And that should be up in the.
Any second now.
Let's see.
You might need to click share
Oh,
screen,
sorry.
Chuck.
Hold on. Sorry.
No
Yeah, I
worries.
clicked off of it. A little too fast on the draw. How about that?
Okay, very good. And you know, again, Chuck was here about 6 months ago. The recording is up on the SNARS YouTube channel. Fantastic. He's back today to talk about grounding, lightning protection, and some other audio sources. So thank you, Chuck. Take her away.
Okay. Well, thanks again. Yeah, like I've mentioned before, I'm with ABR Industries. We're primarily known as kind of like a wire and cable house. But in the prior life, I dealt with a lot of grounding and lightning protection. Kind of tried to keep this pretty specific and direct. Obviously, any questions can certainly take as well as we go. Realistically, just wanted to focus in the what's in it for me as a ham, and kind of, you know, focus on some of the things that need to be done. Because for a lot of hams, you know, grounding their system, there's a lot of questions. Some people seem to be just struggle with it or a little bit afraid of it. They're afraid they're either not doing enough. In some cases, some people are doing too much, but in reality, it's a necessary evil of playing radio. So realistically, just want to cover some key level topics. The first one, if this will cooperate, there we go. You know, just to always like a little quick statement or something like that. You know, thunder's impressive. You know, you hear those loud booms, but it realistically is lightning that does all the work. So are we worried about lightning? Yeah, we're worried about lightning, but it's kind of one of those yes buts. The chart I have is a little bit older at this point, haven't renewed it yet, but this kind of shows the typical strikes per year in certain geographic areas. Some places where I'm at are just quick, fast storms, but we get lightning strikes, you know, throughout them. You know, a lightning strike is a really, really short event, right? It's averaging 0.2 of a second, but it's a high current event. It's 18 kiloamps. The lightning isn't what gets you. It's the static and the EMP, because a typical strike, being as hot as it is, being as fast as it is, and as much current, if it strikes your home or hits your tower, you're going to have a lot of other problems before worrying about just the lightning itself, what it did to your radio. But realistically, 99.9998%, according to the latest statistics, is it's the other effects that happen during lightning. It's the sympathetic static. It's the EMP strike, obviously, that makes the most to you. And the static is really kind of where it becomes dangerous in the sense that, you know, it could be 1 kV, it could be up to 15 kV. And it, you know, that damage, once it's going there, it's going to just go to the path, lose resistance, hit your grounding system, hit your radio, and, you know, you got other problems. So quick question, usually just protecting the shack, you know, starting off, like I said, real basic in this, but obviously the copper, tins, and aluminum products are what you're going to find out there. Some things that I do have through ABR, but realistically, you can get this at, you know, a lot of the different hardware stores. There's a lot of companies that sell lightning protection packages. There's guys that sell a lot of different protectors. So, but from the wire side of it, Copper is probably the most common in the sense of the ground rods, tin copper for inside the shack with braiding, and aluminum, a little bit more on the commercial end of things or tower side of things. But usually that's kind of where you see it. Some people, when they buy into stuff, they don't realize what they're getting. I would say, do a little bit of, there's a little bit of research. There's a lot of stuff online, and I'll cover that at the end as far as resources. But most of the time, it's a pretty direct process. So why do we like copper? Well, copper, as conductive as it can be, it's not quite as good as silver, but it's obviously nowhere near the expense. But the nice thing about copper is it can take a lot of heat, and it's a very good conductor. Even when it oxidizes, the top coating of the copper can still coat or still conduct very well. And because of the skin effect that you're getting off of lightning, it's not only just the direct, quote unquote DC value, but it's the AC that's also implied in there. So usually copper is going to be really a good choice. The only reason why you would want to go to something like a tin copper is because you want to have a better connectivity. But when you tin an individual strand of a smaller thing like a braid, it's really good for indoor use. It's not always as good for outdoor because you want heavier gauge sizes. So the real meat and potatoes of grounding is really kind of the same stuff. A lot of people have known year in and year out, especially with a lot of experience. There's a lot of different ground rods, but usually the 5/8, 8-footers are the most popular. The copper coated steel are still what you're going to find out there. I will tell you guys, and I've preached a little bit to some people like, John Miller and I talk about this every so often. The price of copper and steel and stuff has kind of gone up quite a bit, but usually these ground rods, they're pretty common, plentiful, and you can find them just about any hardware store out there. But I would recommend, if you're going to put a ground rod in, drive the 8-footer in there. You can get a hammer drill. You don't have to be as fancy as what the guy has in the picture. Usually a standard hammer drill attachment. You can rent one, or if a club member has one, they're easy to sink all the ground rods that you need to. Now, I'm in an environment where the ground is soft, moist, and easy to work with. A lot of people deal with rocks and other things, so be patient because it is a tedious task to get these things. But once it's done, it's going to last 20, 30 years before you really have any issues. The real big thing that I talk about sometimes with customers a lot is the clamps that are used. They'll get something off of Amazon. It's kind of a clamp. It's not exactly a clamp. Try to get something that either has a stamp. Some of them have the UL listing on the side or an NEC stamp on there. There's, the ones that are stamped, it's not so much that it makes them a night and day difference being better, but the manufacturer has pretty much followed the NEC code when they've done it, and you're going to get a ground rod that's going to last a long time. They're not really too expensive. They're usually still a few dollars a piece, but a decent one's going to go a long way. So the wire, the code really starts with a 6-gauge and greater. Some people use much bigger. They'll use 4, they'll use 2, they'll use 1. Usually 6 gets quite a bit of conductivity and connecting a lot of devices. And what that means is the reason why 6-gauge is kind of a standardized and it's been useful for hams is that using 6-gauge, you can generally get enough conductivity between a radio, a tuner, and a couple of other devices and have a good ground. Now, some people have multiple radios in the shack, and instead of using multiple 6-gauge wires, which you can simply do because you want to tie to one point and centralize it, is just go up in gauge size. And typically I see people going up to 4-gauge or 2-gauge. 2-gauge is a little bit of an overkill, but 4, if you're going to run about up to 10 devices, is still pretty good. And that's an equivalent. What that means is that 6-gauge is approximately about a 1/2-inch strap, and number 4 is equivalent to a number 1-inch strap. Now, this is where the next debate comes in: coated, uncoated, bare, or stranded. Stranded works really well because it's easy to install. So for peace of mind, I'd always recommend using a stranded. I personally like the PE coated. I know it changes a little bit of the conductivity curve because it is a coated, but most PE coated stranded really does a great job. It lasts a long time. And in an area I'm in, because the copper not only oxidizes, but the grounding, the earth itself has a lot of other chemicals in it. It starts to break down the copper and it oxidizes pretty prematurely because generally speaking, stranded copper will have anywhere from about 4 to 10% oxygen that is usually blended through when they make it. It's because the copper is so stiff and rigid. It helps to keep it stiffer, but usually the softer the copper, the less oxygen you use. But that becomes problematic is that it can become weak and it can break, or somebody tugs it or hits it with a lawnmower or a weed whacker. So the stuff out of the hardware store is great, but I usually prefer the PE coated. There's a lot of guys that are as right as rain. Bare is really kind of still the standard, the de facto standard as far as the way to go. It's really can be very difficult. Now, that being said, you can get copper coated aluminum nowadays and still get the same decent grounding effect by doing it that way. The only thing there is if the copper becomes nicked and it becomes a dissimilar metal, it can sometimes change the performance curve. So usually solid bare copper or the bare stranded stuff will work. I did put down the aluminum copper or tinned copper. Like I said, copper is by far the biggest, most popular type. I prefer tinning. The only reason why I like that is because I not only crimp and clamp everything around, but sometimes I'll touch it with a dab of solder against the ends, just because once I cut it, I want to make sure it's clean. Aluminum you can still use. It's very popular from a commercial standpoint, but it does have a couple of other challenges. And in some cases, the heavier the aluminum gauge, you sometimes have to use a chemical welding process to actually get it to remain stable. Real quick, tower grounding, it is a straightforward process, just a bit depending on the number of legs that you're going off of, and then grounding around the shelter. Usually try to tell people, try to keep about an 8-foot spacing, about the length of the ground rods between the two. Now, this isn't always an exact science, and we don't have nice, neat, square properties sometimes, myself included. So grounding is the most you can make of it, but generally you can get away with 1 ground rod per leg of a tower, and putting a ground rod, typically you can get away with even 10 to 15 feet if you choose to, and put it around a perimeter, or you can put it as a straight line. See, the big thing about grounding is a lot of homes weren't grounded very well and they're very imperfect. So you're not only trying to ground your shack, but you're also trying to help the grounding in your home overall, because once it goes to the path of least resistance, gets into the house, it can hit everything. People have lost TVs, stories of people losing microwaves or other devices. So generally speaking, doing something like that. This picture shows a commercial setup from the cellular system from one of the guys, big players out there. And that's the practice they typically follow. But it's not something that, like I said, you have to go to that extreme because of the number of devices or pieces that they're using. So getting a little bit further, into it, that was kind of the grounding rods. Now we'll talk a little bit more about the lightning protection, which is kind of probably more of an interest for people. There's a lot of different lightning protectors out there, and there's a lot of people that say they claim they got the best. They have the most reactive. They have, the cat's meow as far as grounding goes. Grounding is lightning is broken up into kind of a couple different areas. There's gas tubes, and there's quarter wave stubs, and there's spark gaps. The spark gaps really are old technology. It's in that bottom picture that you see there with that SO239 to a PL. They really only ground, or they only are effective to up to about 500 volts. And usually I try to tell people it's okay from an automotive standpoint, or if it's a truck or semi, they still use them because they build up a lot of static in the road. But for most people, for automotive applications and for other stuff, I generally try to tell people to stay away from them. You'd be better off spending your money, and in most cases, just buying the gas tubes. And the reason being is the gas tubes have really gotten better in their response times, and they're starting to work quite well. They are extremely broadbanded. For most people, they don't need something from DC to 6 gigahertz. But the only reason why I mentioned the DC component is if you are running a device, for example, a satellite or a control system that goes through the coaxial line, you want to make sure it can pass DC, because a lot of them start a little bit higher and then block the DC component, and then your bias T doesn't work for your device. So just heads up on that. They'll generally run a little bit more expensive because those tubes cost a little bit more, but they're a small little cartridge. They're only about 1/4 of an inch, and they just fit into the top cap. It's kind of hard to see in the one picture, but you see with the M double female with small little cap on the top there, it just unscrews and you put a new one in there. A lot of the lightning protection, one other thing I keep trying to tell people is when you do put the protector in line, there is a little ground tab in there. It actually does help just to put a short piece of wire and connect to that. I know a lot of people put the bus bars and plates and stuff like that. But what happens is that little threaded eyelet that's there actually acts as a shunt for static. And so even though static will dissipate along the ground plane inside the tube, you really don't want it to get to that point. So don't forget to connect that little wire. It'll make yourself a lot happier in the long run. The other thing about them is they're very versatile, a lot of different connectors, ends, UHF, the female SOs, BNCs, SMAs, DINs, you name it. So that's what you're going to find out there. And there's a lot of brands out there that really do a very good job with them. A lot of people know Polyphaser. I used to work with a European company called Cuber Sooner. And, for that, back in the day when we started doing this, instead of doing the gas tubes, because the reaction time wasn't always the best, or was using quarter wave stubs for hams, it was impractical. But for higher frequencies, it's in the middle row there, it's the right-hand picture. And it has a specific response time that was usually about, it was less than a millisecond, and it was really fast as far as its grounding and its wave performance. So it almost acted as a filter too. But they're just extraordinarily expensive. They're like $400 or $500 a pop. I don't always recommend them to people anymore. It's one of those things that, like I said, the gas tubes, and you'll be happy. A lot of them just take a look at the specs, because you want something that's going to handle, quick charge up to the 400 killamp and the 100 kV. And that's pretty much a standard for a lot of the tubes, but there are some generics that come from overseas. So some of them get as low as 5 kV. I saw one the other day and it was only a 10 amp or 10 K amp. That was not going to work for the customer, explained it to them. So it's one of those things that you can definitely get a hold of. At ABR, we don't particularly sell a specific brand, but I'm, like I said, more than happy to recommend a few different brands out there. If you have like the Polyphasers, the Alpha Deltas, a few of the others, you'll definitely get some good performance, and they do make some nice products. A couple of other things on coaxial grounding switches. Switches can be really noisy and nasty, and they can have challenges in there. Like I said, some people, I've worked with the guys at Alpha Delta for a number of years. They make a number of decent, really good switches. They're got some heavy bodies on them, and they come with little arc plugs in there. So just something to keep a little peace of mind. Also, because lightning is not the direct hit, and it can just be sympathetic static, depending on where your switch is in line, right there at the end of the shack, it can also help you. So just something to take into consideration. Grounding buses are great. Now, grounding buses, I really try to tell people the best place to do it is right outside the shack if you can. If not, inside is okay, but use like a flat plate surface. And usually with grounding buses, try to use standoffs. And the reason being is you don't want something to, if it does get a zap, you don't want it to sympathetically go through the stand of the plate itself and into the wall. So trying to have a sandwich piece of metal or some other, or sorry, wood, I apologize, or something else that will separate it from arcing over. It doesn't take much. A lot of them do come with standoffs, so it does give you a good place to attach it to. And then from there, you're pretty much good to go, because a lot of them have the holes pre-drilled. And then you can put the lightning arrestor through and then obviously tap the ground wire to it. This gets back to one other question, which is how do I tap to devices? Usually it's from your radio to a grounding plane, like the bus bar, and it's a direct one-to-one connection. When you attach from the radio to a tuner to, let's say, a meter, and then from the meter it goes to the grounding, it's going to change from one piece to the next to the next. And that can sometimes be problematic, especially keeping a decent enough ground. So it's always best to try to do a direct line from the device to the grounding bus. A couple of other things to consider. People miss their rotors sometimes. It's easy to do, but there are some really nice multi-conductor direct shunts to ground. Just running the rotor wire out there to the different eyelets, connecting the little Y connectors, and then just matching it to the thing and then letting it do its job. It's a capacitive discharge in a sense. So the nice thing is it gets rid of any noise that could affect your rotor anyways, and helps to smooth out the power that goes through the line. So something to definitely keep in mind and worry about there, because I hate to say it, but rotors are really expensive, and it's a kind of a really low cost investment for long term. The other piece is your CATV protection. It's more for satellite. The stuff that's coming from cable is buried for a lot of people anyways, but your satellite's sticking out there, that piece of metal, a lot of hams have an antenna that's close by or something else that could leak from one to the other, and then bust that out. Some of the guys that install satellite are smart enough to put in a filter right there or put in a protector right there anyways, or the multi-node is got one built in, but it's always like I said, a simple investment, and it's generally overlooked by a lot of people. And then some other questions coming into the thing is, what other things do I look for? One is, your particular market, depending on how conductive the soil is. Like I said, where I'm at is generally really, really lucky. But if not, there are carbon fills. This is one from Harder, but there's a lot of brands out there. They're definitely easy to obtain. They cost a couple dollars. They'll start to lower the soil resistance and help see a lot of it in the different rocky terrains as they're driving it through. So that is one piece just to take in consideration. Usually you use the ultrafill and then cover it again with rocks, as you've got your ground rod in there, and then use the ultrafill, cover it with rocks, and you're good to go. So it doesn't exactly blow away either. Perimeter grounding, there's a lot of products out there that actually can do, several ground rods or planes and do it in a kit. It is something that if you're totally not sure and don't have any resources, a lot of the clubs have got guys with, some very practical experience when it comes to grounding. So, but if not, and you're just completely unsure, there are some kits out there. And then for some people, for higher story buildings, some rooftop grounding, they coincide with some lighting products. I don't see a lot of hams really needing them, except for the guys that live in condos and stuff like that, where the condo association may say yes, but how are you going to, protect us from lightning? There's some products there. Like I said, I'm really not touching anywhere near kind of what you would need to set up for this, but if there's any questions, I can always answer them or answer them later. So the other piece of grounding is, why do we do all this stuff? Why do we all worry about this? And it's really because of the RFI EMI management. I'm not going to read this all together because it gets boring in a hurry, but obviously we know what radio frequency interference is coming from unintended other transmissions. But it's really kind of the thing that surprises people, that there's really a lot of the EMI in a household. My house is no different. It's kind of always nice because I can share a direct example. When the dishwasher goes off, the EMI bleeds through the grounding line, and I had to fix it and get it taken care of, which was not a problem. But you can get it from a lot of different sources. So, when we talk about anything wireless, it is anything wireless. The rule of thumb is shut everything off and then start to worry from there as you turn things back on. You can grab an old AM radio. You can, listen for noise with some of the HTs that can do AM. But, the old traditional things, Bluetooth, some of the old cordless phones, I don't think a lot of people have those anymore, but some of the low end remote mice are still kind of nasty. And the slide advancers, things in presentation, things in offices. Some of the mobile phones, I think some people are starting to hear more and more about 5G is great, except there's problems with interference now because at certain airports. So this is one of the things that they're actually starting to investigate and look into. You would think with the technology, as long as it took to develop, they would have thought it through. But unfortunately, with some of the spectrum that was sold off, it's just too close to the aviation side. So some of the some of the providers are starting to spend some time investigating that. Some other things, microwave ovens are easy, but one of the things that people don't think about is the fluorescent light bulbs. It's great to get LED bulbs and these compact fluorescents, but some of them are so poorly shielded that they create more noise than they're worth. Hair dryers, some people still have them, with the DC motors. Electric shavers and trimmers can still set stuff off. So kind of a highlight thing is, if you went through all that, some other things, just, anything above a 2 amp switching load. So sometimes it can be a toaster, a blanket, the CRT monitors. Some of the rolling portable electric heaters are a really high source of noise. And then, it goes on. So, when I said it can be a lot of work and it can be tedious, it can be. The one thing with noise is, if you kill one noise source, you've definitely made a positive change. And even if there's another one there, you can always investigate and work your way down as time, permits. And for a lot of people, it can be frustrating, but it is a little bit of a never-ending battle. So for hams, here's the best place to start. Just look at the things in the ham shack. Monitors, LC monitors have really kind of addressed a lot of that from the power supplies, but the old CRT interlaced ones are leaky. A lot of people probably don't have that anymore. They have an LCD. So I don't think you'd really be too worried. Computers. The desktops can still be noisy from their power supplies. The laptops, I wouldn't be worried about at all. Vintage radios, a lot of guys are into that. They understand probably this subject more than I do. But tubes can sometimes have some unwanted side effects. And then the other thing is looking at the power supply. The really kind of low end switching supplies can sometimes have issues. There are definitely easy fixes using ferrites and other things. But it's just one thing to look at. So if you are having noise in the shack and it's coming from, you think something internally, try looking at these areas first. Some other things on the coax side of it. This is kind of, one is, the shielding itself, using a double shielded product will definitely help. The reason being is because a double shielded product can go from, a single shield is anywhere from about 70 to 80 dB is where the specifications are. When you put a double shield in there, you can get anywhere from about 95 to 105 dB of isolation. So double shielded coaxes are always great. The larger the gauge size, the better off you'll be, but don't drive yourself crazy. Please don't go out there and buy a bunch of 600. As much as I'd love to sell it to you, the standardized cables that are out there, even the smaller stuff, there's a lot of double shielded products. And then look at sometimes, if you had to, filters in your system. Some other stuff real quick on the ham shack side, ferrites and chokes, you know, there's a lot of them that are frequency rated. AC line filters are an easy and simple way to do it. You can even build one yourself. They're actually kind of a fun little project to do. We did it with my club and built up a bunch of them. They work great. You know, creating your own grounding bus, getting the common connection going, and then, like I said, utilizing braid, because some people just use some small single end wire that they have, sometimes discount that they don't need something big, but braid can actually help quite a bit inside the shack. Then a couple of other areas for those that are mobile, batteries, you know, the higher cranking requirements that are out there, because the alternators, actually other sources, the reason why I say these things is we had a municipality about 4 years ago we were working with, and they were having trouble with the cabling. And we found out that the backup cameras that the police station or the department had put into the vehicles after had actually been so noisy as a camera that they had to pull them all out. So it's not a lot that somebody can individually control, but these are just things to look at. And then the last thing is AC line safety. The only reason why I like to cover this is just please be safe out there. I know a lot of people try to fix things in their homes, try to fix the power bus, you know, the switch and stuff like that, but be careful. You know, a couple of other things. Take a look at the NEC code. If you're not sure, get some help, find some help, hire some help. There's nothing wrong with that. It's okay, because it doesn't take a lot to hurt a human being. If you are working on power in the house, or you're working on something to protect your home, please lock out the system or shut the switch off or something like that before you put your hands on there. I know some people just finger testing is a great way to make sure if there's power running through something. Please don't. You know, getting to know your home, call before you dig. You're running ground rods in. Make sure you're not going to hit that gas line, hit anything else. Knew somebody that drove a ground rod in, didn't realize that he actually had a new home. Said, oh, it's fine. It's over on the other side of the house where the power box is. He didn't realize that it actually ran pretty much along an L shape along his backyard and tapped into his power for the house and pretty much shorted out the home. Thankfully, he was okay. But make sure to call before you dig. And that's it.
Okay, Chuck, thank you so much. Leave that information up, and people need to get hold of you. They can do that. So first of all, thank you for your presentation. Very power pack. It's recorded, and we'll get it on the SNARS website. Thanks for taking time on your Saturday of a holiday weekend, Chuck.
Anytime.
Okay. Yeah. So what we're going to do is we're going to take questions in two groups because of the technology set up today. First, we're going to take some from the Zoom side only, and we can mic people. And then when we're done with that, we're going to do the in-person side. We have a hybrid today. So let's go to the Zoom side. If you have a question for Chuck, raise your hand. The way you do that on Zoom is on most of the devices, you click on reactions, raise your hand. So that's the best way to do that. While I'm going to start off with a question while the questions are coming in, Chuck, and that is, there's this ongoing question that comes out, oh, I just have a small station, or I'm just running 100 watts, or I don't have a very big antenna at home, or whatever. Oh, only the big guys. This is some only the big guys, only the big towers have lightning arresters. So I just wanted you to talk about that for a minute, also in relation to, well, somebody will say, I just disconnect my antenna when there's lightning. So if you could just kind of talk about that for a second, because that's sort of a thing that's been going around for as long as I've been a ham.
Sure. So, well, first of all, for the first portion of the question, why put a lightning arrestor in there at all? It's a small station, or there's not much going on there, or I don't think it's going to, everything that, lightning, because its presence it can affect everything equally. And that means you have just as much of a chance of getting some sympathetic charge in your small station as the big piece of metal, the tower outside, or the lighting pole, or the power transformer, as much as it all can just blend equally. And as an investment into your shack, a lightning protector just leading in off the coaxial line, and there's ways to even tie it right to the ground rod outside your shack. Even at bare minimum, you're going to do two things. One is you're going to increase your ground presence, so your signal is going to get better. And two is at minimum, you're going to get rid of any static or noise or anything else in there that could affect your front end of your receiver and then eventually blow it out anyway. So it's not a guarantee. There's a lot of people that just take the risk and move on. But there's a lot of times where when somebody loses something, they've lost the radio, and then it went through the power supply, and then they could affect something else nearby as well. So it's, and the lightning protectors, if I remember correctly, they're about $50, $60 for some decent ones. They might have gone up. I don't know entirely, but like I said, it's a low cost investment. And like I said, it gets rid of the static, which once again, it also helps you. So that's kind of the reason why I always preach it's a little preventative maintenance, and it helps your system. The second piece is, well, shouldn't I just disconnect it and I'll be okay? I could put it in an old glass jar. Yes, those things worked, but I'll share a story, and this happens between my father and I when I was growing up. We used to just do a manual disconnect and disconnect the cables that were going into the shack in the basement. We disconnected the cables. We actually had a sympathetic strike that actually went down the line, jumped from the cable, and it jumped about 5 feet across and actually hit the sump pump and burned out the sump pump in the house. So usually just straight disconnection, as much as that can work and has worked for people, there are some hazards there, or somebody forgets. And in our case, it was a simple thing that we just did. We thought, that was the right thing, but it had an unintended consequence of like I said, burning out the sump pump, and it arced right through it. So that's the thing that can happen there and affect people's systems.
Really good. Any questions from Zoom, just raise your hand and we'll get you in the queue. I know of a story, and I'm sure we all hear these. It was somebody in San Diego years ago where they didn't have, had a tower and some other stuff, and he didn't have lightning protection. It's not to say that lightning protection will work 100% all the time, but short to the story is it was one thing when it came down the coax and it was radios up, but it was another one, it arced all the stuff, all the stuff in the house, and then it caught on fire. So I think the other thing is some people will say, well, okay, so I'll disconnect the cable and put it to ground. That probably helps. Question is, are you home when it happens? We had some lightning up here in thunder and rain back a month or so ago up in Reno, so it can happen anywhere. Okay, not seeing any questions so far in Zoom. Let's go to
Howard Holden is actually raising his hand in the picture. So I don't know.
Let's go to Howie. Hold on, Howie. Thank you so much. I'm not looking at the picture. Let me get you Howie onto the mic here. Okay, Howie, go ahead and undo your mic.
Oh, I think he's still on mute.
Howie, can you unclick here, I'll do it a different way.
Are we unmuted?
Howie, go ahead. Very good. Welcome. Thanks, Howie.
Okay, good morning, Chuck, and a nice presentation. The question I have goes back to the beginning of your presentation. You talked about lightning and skin effect. Lightning is DC. Why would it have skin effect?
Still has a frequency component buried into it.
Okay.
That, based on the timing that it goes through, and it's such a broad band. Lightning, you know, generally speaking, the skin effect will generally stop at about 10 to 15 megahertz as far as the frequency component that's involved in it. But there is sometimes that it goes up higher. So even though skin effect truly doesn't take its full form until it gets closer to about 1 gig, it has been measured and there's been a number of studies on it. So it's always good to kind of mention it just because it's an unintended consequence of the bolt itself.
Okay, thank you. Thank you very much.
Okay, very, very good. Thanks. Good question, Howie. I'll tell you what we'll do. We'll come back in a minute to the Zoom side, and in the meantime, we'll go to the in-person. If people have questions on Zoom, raise your hand. We'll get to you in a minute. So Tyler is going to help us on the other end, on the technology end there. So who in person has questions? Tyler, can you help on their end and ask them to raise their hand and call on them, and then we'll do some magic. Go ahead, Tyler.
Yeah, there you go. There you go. We'll have an echo.
You want me to come up there?
Yeah.
I can repeat it for you. Go ahead. I'll just repeat it for you.
It's kind of long.
Well, then what?
Stand by while we come up.
But the simple answer is no.
So can I do this?
Yeah, just talking.
Okay, it's a heck of an echo. So I wanted to make one comment. The reason there's an AC component is because the current is switching very fast on a lightning strike. So that impulse edge as it turns on is what creates a frequency component. My question for you is on the protectors. Do you put them at both ends, at the antenna end and at the radio end, or where do you put them?
So generally it's better to put them as close as you can to the antenna side of things. However, for a lot of people that becomes difficult to somehow get installed, because what happens is you want to put it as close to the ground. So if you have an antenna, say 30 feet in the air, you want to put them at, you know, the base of where that antenna starts to get down closer to the ground. Although a number of people, they feel more comfortable putting them in at the shack, because the further it's going to traverse, the more damage it's going to do to the coax itself, right? But in reality, if you only have 100 feet of coax, 100 feet's 100 feet, you can put it in right at the shack point and put a grounding in there and, you know, get everything, you know, commonly grounded at that point, because you want to make it as easy as possible. So like I said, there's kind of the direct school of thought is, you know, do it right as far as you can, as close as you can to the antenna end of it. You don't want to put it up in the air though, and, you know, running a grounding wire can be problematic on its own at that section. So that's kind of where it's kind of whatever best practice you can put into place. And for a lot of commercial installations, they have a tendency of grounding, like I said, right at the base, but the base also holds the doghouse. So it's easy to do all at once, especially on like cellular side of things and stuff like that. Broadcast engineers take a lot of different tactics to do it right at the antenna side, because they may feed it through, get it through the equipment, and have to have much higher isolation. So that's where they're going to do a little bit differently, closer to the antenna.
So right now, I disconnect my coax in the shack when I'm not using the antennas, and I put them in a jar full of BBs. It sounds like that's still not good enough.
No, it's not that it's not entirely terrible. It's the two things that are hard is one, making sure that, if you're doing it every single time, you got to get it done before you leave and stuff like that, or make sure that you kind of have that standardized practice. The lightning protectors, were designed for people like me that, either, aren't always around, or, unfortunately didn't always disconnect everything before they walked away, and did it that way. So that's why the jar method it's okay, but it's a really kind of older methodology to do. That's all.
Okay, thanks for that question. Got about 8 minutes to the top of the hour, so we got time for some more questions. Anybody there, person there, Tyler, also has a question, and coming up to the mic is great.
Anybody else? Looks quiet.
No, the thing, Chuck, you were saying about that the beads and the grounding of the cable, if you do it physically, the biggest issue is, are you there?
Right.
When are you there? Are you at work? Are you out with a friend? Did you get called out of town? That's where the issue lies. So, for a relatively inexpensive ground rod and a couple connectors on the cable and a lightning arrestor might save you. I do have a question. What determines when you need to change those things out? If there's a lightning hit, is there a fuse kind of thing? Is there on the protector, is there some indication that it's been brought?
Yeah, that's a really good question, actually, because that sometimes gets overlooked. Is that, reasonably speaking, the static arrestor, over time, it will take enough charge. The gas in there technically becomes a solid, and then the SWR goes through the roof. So if you measured your SWR and your, ideal, let's say 1-to-1, all of a sudden it creeps up and it's getting to 2-to-1, 3-to-1. Check the static arrestors. The little caps, like I said, they're easily unthreaded. You just take the cap off, you can throw it away. And then as far as the replacement goes, a lot of hardware stores sell them now, because they actually sell CATV, the cable TV stuff with the arresters, but you can pick them up at them, any electronics places. The caps, or the devices themselves, just to give everybody kind of an idea of how much it is, they're really inexpensive. They're probably only maybe $5 to $10. I mean, they're really cheap to pick up, and they work pretty well. And there's a ceramic model now, which is nice because they're even less expensive than the old glass versions. So I think Bob Dickerson was raising his hand also, just to make a quick comment as well.
Thanks. Bob, go ahead and open your mic. Oh, here, let's get you. Okay, now you can open your mic.
Here we go. Chuck, thank you very much for your presentation this morning. And I worked in commercial telecom for years and years, building transmitters and sites. And tell me if I'm wrong here, but on your mathematics, you showed the normal, your 10 kiloamp or whatever. But it's my understanding that lightning is measured in kiloamperes per microsecond rise time. Is that correct?
That is correct. I took a shortcut when I labeled the data.
So if you take a 30 Ka kiloamp strike on your neighbor's house and it's trying to be dissipated into the ground, oh, wait a minute, what are you tied to? His power line is tied out in the street to your power line. And if you don't have lightning protection or static protection on your systems, your neighbor could take a direct hit to his home. I got a 40-foot tower sitting outside right now, but it's got a number 4 ground and 2 ground rods sitting on it. But years ago, when I was working in the industry, we took a direct hit on one of our VHF low band transmitter sites. The antenna got hit, and as it came down the transmission line and through the ground system and the shield of the transmission line, which was grounded at the base of the wooden pole before it went into the building and into the bus bar ground system with polyphasers on it, it still came inside the building. And the equipment was in a 6-foot tall steel, regular, 19-inch open rack space. All the equipment was bolted there. And wherever there was a screw attached to the mounting plate and to the frame, there was a blast mark. So lightning is extremely dangerous with a direct hit. But as you said, you're incidental. In other words, you got two ground rods, one at the base of your tower and one at the bottom of in my house. I've got a ground rod maybe 40 feet away from the tower. So the tower is grounded with an 8-foot rod. There's another 8-foot rod outside the shack, and there's a bus bar there, and lightning protectors are sitting down there. Then the cables go up into my room on a second story. So, you know, it's just do everything you can to get them grounded, bonded. It's reduce that incidental.
Absolutely. Yeah. And I mean, yeah, like I said, it's hard that's the one catch-22 of explaining it is, you know, the direct strike, you know, commercially, you guys plan to get direct strikes X number of times over a period. Usually I think it's a year or two for some of them, and it can be several hits. So yeah, there's definitely, you know, the systems are also, like you said, designed to handle all of that in comparison to, like I said, an average home, which is nowhere near going to be ready for that. So that's the reason why I focus more on the sympathetic side, but you're absolutely 100% correct.
Okay, thanks, Bob. You know, towards that, when I've driven through some of the different states, I don't remember where, maybe the farmlands of Idaho, I noticed that on the big, huge barns, they have some lightning, I don't know what they're called, but there's little stakes up in the sky, you know, top of the barn. I'm assuming those are to go to ground. So if lightning does hit, it's not relation to RF ham radio, but it goes to ground. Okay, so thank you, Chuck. On behalf of the Sierra Nevada Amateur Radio Society, thank you so much for your informative presentation. Chuck has been a great supporter of SNARS, has some business relationships with some other people here in the club, which is fantastic. I have bought recently, myself and a friend bought some coax from my ABR, was very happy. My own personal plug for them. Turns out I got an email that they're having a sale this week for Labor Day. So go check it out if it's of interest. Anything you want to say in closing, Chuck, about lightning or anything?
Well, I do appreciate everybody's time. Like I said, and it's always good to talk to people, get their varied experience. It helps educate me also. And it's always good to know, you know, and it's something to share, just something that, you know, people don't always think about or they're afraid of, but it's something that can easily be remedied. And a lot of people can do very simple steps to help their system out. Because, you know, the whole point is you want to be able to have fun when you're on the radio also to a certain extent. And I know there's a lot of places where it's very serious, but, you know, the whole point is, you know, go out there and enjoy yourself because it is a wonderful hobby. And, you know, I think a lot of people can have a lot of fun with it. So thank you again. Beautiful.
And on the screen, and I'll just say it auditorily, if you need to get hold of him, it's Chuck Abramson, ABRAMSON. It's Chuck at abrind.com. Cell number 713-492-2722. Thank you so much. We'll let you get back to your family for the holiday weekend. With that, this completes today's SNARS meeting and presentation. Have a great Labor Day weekend, and we'll see you next month in November, in October. The October speaker will be Jim Shepard, W6US. He's going to be speaking about Nevada QSO Party. Thanks, everyone.
Thank you.